Good evening, everyone. How y'all doing tonight? We're excited to be here for seeds, and we're Stock Sentry. I'm Jeff. This is Danny to my left. We have Sean. We have Noah with a nice hat on, and we got Matt, our project manager. And we're just going to jump right into this thing. So, Dr. Mazzaro, I don't see here, but Mr. Knapp is, who is one of our clients for this project, noticed a problem in the EC labs with supply chain management. Stuff gets erratic. Students blame professors, professors blame students on where all the equipment is. So obviously looking and running for equipment allows for waste of resources. People get angry, demos don't happen. So Stock Sentry's goal is to create an automated inventory system for all the 3 labs up in Grimsley Hall, the main lab being 311, 304, and 307, which are the 2 subsidiary senior labs.
Some significant changes were made throughout the year of senior design. One being the addition of the anti-theft module, or the camera module. Our client expressed interest in seeing photo evidence of people going in and out of the labs, trying to steal our equipment. The second major addition was adding the router. We were heavily deterred by Citadel's IT department of running wires through the walls and the ceilings. So we have a router to communicate all of the data receivers between all 3 labs. And finally, we had a significant change to the housing of the RFID module as the power supply was causing interference with the capture of the RFID.
So the design criteria for this, most important thing was track equipment going inside and outside the labs. And then with that, we wanted to track the RFID that was attached to that equipment, along with the images that were taken for that equipment. We needed a way to see who last checked out the equipment. So Mr. Knapp and Dr. Mazzaro will be able to go in, verify who took that equipment, and then also look at the images to be able to determine if it was actually them. We needed a way to add new users as students go, and new equipment as we change that out in the labs. It had to be easily scanned into the system, and then also we needed a way to check out that equipment by only the authorized users, not anyone at all.
So our solution to meet all those design criteria has 5 modules in it. We're going to have an RFID tracking module that uses UHF tags. We're going to have a camera module that captures a photo when someone takes a tagged piece of equipment in and out of the lab. We're going to have a data receiver module that kind of centralizes everything. The camera and the RFID module communicates to the data receiver, so it's more central. We're also going to have a database module that stores everything, and that's what Mr. Knapp and Dr. Mazzaro are actually tapping into to see what's going on. And then lastly, we'll have a UI. That's what they're going to see when they open up the program on the computer. And then we also added a barcode scanner just so they can scan their Citadel ID and see what's going on. Equipment tracking module. That's my module. There's kind of 3 main points to it. We've got an RFID module. It is a 3 dBi UHF antenna. It's operating around 916 megahertz. I've gotten probably around 6 feet, sometimes across the lab, sometimes not right up against it. So that sweet spot's kind of less than 6 feet. The Pico cannot output enough power to power the RFID antenna. So I had to add a USB-C breakout board to parallel and separate off. And then coincidentally, behind every single clock in every lab, there is a wall outlet. So I can plug in there.
So I had the camera module, the anti-theft module. For this, I used an RFI 02W. It was the smallest RFI I could use that would work for this, and I used the RFI camera module 3 along with it. It's super easy to integrate, but with it, like the major problem I had was being able to receive a code whenever an RFID passed the doorway, and then be able to take the picture as fast as possible. At first, I used LibCam to be able to get this done, but it proved to be too slow, even if I lowered the image quality. So I swapped over to PyCam 2, and it boosted the speed really quick. And then it also timestamps every picture, the date and the timestamp. to be able to send that information along with the image to be able to track it back to when it happened. And then it will send that to the data receiver, which will be stored in the database after that.
Okay, so I have a two-parter for the module that I did. This was the equipment and user ID. So we actually call that equipment checkout and user authorization, which we needed a simple, consistent way to do. So we went with the 1D barcode, which allows you to, as an authorized user, being an admin or a student, and some of y'all got to play with this when you were up there. There's that ugly mug right there for people who want to use your cell ID. That allows you to not have to have a PIN code or try and lose something, to not be able to get into the system. And then, of course, we have all the gear that we've purposely done unique identifiers, which are our own custom-built code that actually matches RFID and barcode to a equipment serial number so that you can scan it in. So everything can happen with our COTS custom over-the-shelf scanner that allows you to go in and basically start working with the UI. And the other part of that module that I did was the data receiver. A little bit more important and a little bit more involved with it. As Matt and Danny said earlier, this is the central hub for the data in all the labs. There is a working data receiver in all 3 labs that has to talk to the RFID reader, and when it receives a cue from any piece of our custom tags that come through the door, has to be able to trigger the camera to engage the anti-theft module. So there are scripts written on that data receiver, startup services that talk to both of those guys. The anti-theft one is more manual that we're working on to try and automate before final delivery, but I think I wanted to add, just over in the corner here, everybody's seen this is a Raspberry 3B Plus. I did like to have the CAD file version because it shows the heat sinks we installed on the CPU, LAN, and the CPU, LAN, and there's one more. I don't remember what it is off the top of my head. But yeah, so that is it does have an external display so you can run diagnostics and see data coming in each lab before it goes to the systems router and database.
So again, I was in charge of the database module. The hardware I was using, the database lives on a Raspberry Pi 3B Plus, same as all the other data receivers. And the storage unit to store all of the images being taken and all of the user information, the equipment information, including RFID tags, they're all stored on a USB drive. This was all coded in SQL, very run-of-the-mill standard stuff for database creation with using MariaDB as a management system. The database has 3 main tables, one being the user table that houses the users that are able to interact with the UI, as well as any permissions that they may have, being admin or student. The equipment table, that stores any of the equipment information going anywhere from RFID tags of the specific equipment name, as well as the locations of where that equipment will be. Whether that's lab 311, 307, 304. And lastly, the image data table. It captures the timestamp of when a RFID is scanned through the door, image is taken, time-stamped, and there is it outputs a file path to that image so that the UI, you can see that image in the UI.
Yeah, so I was in charge of the UI. The UI lives on, it's a program. It can live on any of the 3B pluses, but currently it's on the 3B plus in lab 311 to allow you to check in, check out equipment. The home screen looks kind of like that. Once you're logged in, the login screen here is on the bottom. Using Python 3.11, that's what I used to code it. 3 libraries were used. Tkinter for the application made it pretty simple, just kind of taking building blocks and putting them together. Really helped my lack of Python knowledge, just to kind of more of a project management planning standpoint for the code rather than trying to get intense code knowledge. Pillow was my image library, helped me display images, no other way to do it. And then MySQL was how I connected to the database to query and get information I needed to actually make the UI work with real information. The architecture, like I already said, we have a UI login screen, your home screen, and then you can choose all these various options depending on your user level.
So our current status is we did pass Demo 4, and we did get a lot of users today to come up and play with the system. It was interactive. We do have a working system in all 3 labs, and it already looks like there's buzzing interest to expand on that. We do have an error bug in the system that there's some crossing between a couple of tags that we're working on. I think it'll be kind of a simple fix. And we have also an error in RFID that's being picked up in one of the labs that we have a possible code solution to fix. So that's where we are.
Our deliverables, every photo here is what we're actually going to give them. So we have our 3 cameras. We had to do our own router because we got blocked from IT again. We have a data receiver that you can hook up a monitor to see what's going on, but you don't need that to run the system. The only monitor you need is the one with the database and the UI down there. And then we have our RFID module. Every camera in here, that one is outside 307, the bottom one is 311, and then that long one is right outside 304, so we can track all 3 of them.
Milestones achieved. We've successfully integrated the anti-theft, equipment tracking, and data receiver modules using wireless communication through that router like we were talking about earlier. We successfully integrated the database with the data receiver using that router, passed all 4 demos, and created a significantly cheaper alternative to RFID inventory management.
I'll talk about our budget real fast. Overall, we had a $1,000 budget like everybody else. We only spent about $700 of it, which is much, much cheaper in comparison to current market options. It can cost upwards of like $300 for just a 2-foot door scanner that doesn't actually scan 6 foot like Matt's scanner does, for a price of $60, roughly, I believe. Right? Yeah. Yeah, it's a huge achievement to reduce price on a system like this.
So basically, in summary, we've created a working automated inventory system, and we did stay significantly under budget, and the future work depends on how you guys want to make this thing expand. I mean, like I said, we have a lot of interest in it, with the civil lab and the other departments, so even athletic gear could go anywhere. So yeah, we're pretty proud that it was a deliverable system. And I'll make this quick, even though I wish I had more time to say it. I want to thank this team up here because this is an important day for me. I'm really proud of these guys, and you all mean a lot to me, and this was a very learnable and educating experience. We thank Dr. Agarwal for his key insight, especially towards the end, and the demos that we were doing, and we absolutely thank the most important person we think in this room, who is our 6th member of the team, Dr. Davila. I think that's it. Questions?
Sean,
Yes, sir.
the database stuff,
Yes.
is this what you learned in Computer Science 320? Is that database class directly applicable to the database stuff?
Actually, it very much was so. Yes, sir. I learned a lot of how to query into a database, how to create one, how to use foreign keys, primary keys, move things around. It was very, very helpful.
You want to make sure the right course is in the curriculum.
Absolutely, yes, sir.
You mentioned the timing aspect of it, detecting the tag and taking the picture and having to kind of coordinate that. Was there any idea or any exploration of keeping basically just a running, not a video necessarily, but repeatedly taking pictures and just discarding the oldest ones, so you actually have a history, so when it detects the tag, you can actually say, okay, show me 30 seconds before that until right now, or?
We do have the ability to do for the history, to be able to track. Each image does let you, it gives you a timestamp specifically on that image. Danny might be better on this than me, but I know that there was some latency and lag. He did work on a lot of the parameters for the image to be able to mess with the resolution, because there was some latencies between queuing from RFID to the image being captured. So I know you had a little bit of,
I think the biggest problem was getting the image from my ARPA to the data receiver was fine, but then sending it over to the other lab through the router was the biggest Most of the images were corrupted if they were too big or if they took too long. So we're really sizing them down and then being able to send only what we needed to be able to reach that lab. That was the biggest problem we had.
So I'm a big fan of the button, but in all of those rooms, they have a big red button right by the entrance that turns off all of the outlets. I put a lot of effort to figure out what that button does.
UPO.
And so what would happen if someone popped that and then tried to leave with one of the things you brought back?
They would successfully leave.
But
But everybody would know it because they'd probably take the whole hallway down. So that's an emergency power off button is what you're talking about.
So the button's downloaded.
Yes.
Except for the button knocks out the OS.
Yes. There would be bigger problems with some of the rooms.
It's a net.
Any more questions? Thank you very much.
Thank you very much.